Okay. So I'm pretty tired, but I'm going to have a little bit more of a play with this. One obvious thing is that this needs to be increased. So I'll just give it another go now. What am I expecting? Well, what I'm hoping for is... Well, actually, you know what? I will go back to simplicity. Two recursions. Let's see what three recursions. So it should look like that basically. My gradient setup is this, with high -1, which means this line never crosses itself, and my line drawing seemed to be so sort of correct that it would never cross itself. The highest point in the render should be 1. And so with the high threshold set to -1, anything with value 1 should appear at the top of the gradient. That is it rendered. And there it is. Now, it will be a fairly kind of brutal render, yeah, look at that, compared to the OpenGL draw. But that's kind of the point, because this is much more about capturing exactly the number of crosses of an individual pixel and having that possibly be one of many, many different states close together. Now, I'm curious about some things. I'm curious about how long it takes to render that. I'm curious about how different things would speed it up, changing the array into a data buffer. Working on this loop so that I basically wasn't making function calls, or making very few. Also, can I assume this is right? Because here's a test. Let's make this color red and just do the same again. Right. So that is in the wrong order, the colors. That's not a problem. That's one thing that's fairly easy to sort, and actually does bring up a thing about how I could avoid making function calls here. And one of the things I could avoid doing is using a color at all. Set pixel wants an ARGB value. The gradient, once I know the value, I can query the individual splines separately. I could divvy it up here into is GV1 or not. That is annoying. An alternative is to just limit it to just below 1, and then I don't have to do the extra test. But, do I want to do that? Well, these are the questions. Is a databank going to be significantly faster? is breaking this up. I will have to, I guess, fix this now. You know, I have no option actually now except to fix this, because if I'm going to do further testing, I want to know and to be able to predict how my output will look. I'm very honestly delighted in a way to see this image, even though this is the wrong color. Doesn't matter. Oops. That's what I wanted. To see it emerge, having drawn the lines myself, is a kind of delight. Let's just hope all the overlaps with the edges of the display and everything continue to work. They did appear to be working. I saw those outputs. So the first thing, I suppose, well no, the very first thing I'll do is fix this. And in fact, what I'll do is I will not use that. I've got GV now, and I can just get in here, have a look at my GUI global, my GUI classes. This I think is the one I want, because I want to you see, this is what would be passed to OpenGL. This is a part of it I don't understand, and a bit of it when I've been nosing around inside Mojo, the monkey module. I've understood that this is what they do in order to make transparency properly work, to make the sort of incorporate the alpha value into all of the other parts of the red, green and blue components. And this is it, just represented with the alpha value as one of the components. Now to me, I don't understand why it is this doesn't work and this does work. And it's a peculiar sort of relationship. It's not worth going into. The question I'm trying to get to is, do I want this one or do I want this one? And I suppose what I want is I want both, and I want to just play with them until I see what the results are. And I want to tab them in, and what I'm going to do is start with this. And it's not going to be called V. I'm going to try and get away with not having something like that. Instead I'm going to get away with something which is an unsigned int, which is ccall unsigned int equals 0. And here ccall will be something. And here just ccall dot av. Wait one moment, I will run this out and just pop in another with actually ccall. And what ccall will be que sera, whatever it is, que sera, this. RGB. What A actually is the current gradient, alpha spline value at gradient value. Well, this saves me assigning things, but goodness, what a long and horrible line it's going to be. And I don't want C gradient. Now here I guess it's red spline value gradient value. This is not taking into consideration that top, like the fact that 1 is equal to 0. I should have an if statement, or I should limit this to just below 1 or something. Green, C grad, green, oh shoe, green spline value at GV C grad blue spline value at GV. So this version of it would be neater. Let me have a little think. Well, this is what's going to happen for now. Here, I have a feeling that if I don't put in a little comma 0.0 comma 0.999999, this is annoying. It's annoying because I do begin to see ways I could just trim tiny, like I shouldn't use limit, I shouldn't call the function, because actually I could just say, again I'll run this out, I'll say GV equals this bit, sure. And then I do say GV, if GV is less than 0.0, GV equals 0.0. That bit happens inside the G limit anyway, but the other bit that happens inside the G limit tops it out. But here, if I say if GV is greater than or equal to 1.0, do something else. Do this. Poor thing. And in this one, you get an even more horrible sum. Which has something called value 1. Fair enough, you don't need this bit, but you still have to have value 1 written. And I think that that should cope with the other eventualities, and it's just trimmed like one little decision and a function call for that matter, and a couple of other function calls. Like, I'm not doing set color anymore. I'm not doing glimit or set color, and I'm doing one less if. And I should be getting the ARGB the right way round. We shall soon see. And then when I've done, well, we'll see. Let's see if I get this right. And it also means I don't have to use a color. I haven't had to, yeah. It doesn't look pretty, but this is better, I think. Did I crash it last time or what? I want the simplicity so that I kind of know what... I want to know that nothing here is crossing. It's a crooked one. Okay, and once again, this is just black to white, high -1, no crossing. 3 recursions is fine. 3 recursions doesn't cross. Static, save, do it. What was that sound for? white, fine. Now this, make it red, static, save. Nice. Now make it blue. Correct. And last of all, green. Now, phew. Now, what I want to do. Now I wonder, I don't think that save worked last time, did it? And that means that I've done something to corrupt my save file, which is hardly surprising. Seems every time I go in that bloody thing, I do something idiotic. Excuse me, how rude. Immediately after gradients, gradient set read, low threshold, high threshold read, prior to frames. Immediately after gradients, write int, write int, right before frames. Is it ints? Read int, read int. Man, that's quite annoying. Don't understand why. I'll have to check next time I run it. What did I come back in here to do though? More importantly, in a sense. Oh yes, timing. A thing which is good fun to think about, but I often forget about. From this moment, how do I do it? Timing. Let's have a relaxing nose through the monkey source. Now I cannot remember where the timing things are. MISC tests. Nope, it's not in graphics anyway. Don't see it anywhere obvious there in MISC. Build, time, timer. I don't think this is it. Microseconds, it is. Number of microseconds since the app started. Okay. This is interesting. Returns now times 1,000,000. So microseconds is what I want. Sorry. I just call microseconds. Okay. So local start m long equals microsecs. Debug right start gradient render microsecs. Now I wonder if I should do something like string start plus sex plus string start float start m divided by 1,000,000. I should probably have something here. Well, forget it, I'm not doing it just now. Is this the way I want to do it? I don't want it as time now, I want it as... no, I don't want it as start time, I want it as time now. And I'm just quite, this is not a thing I do often, so I'm quite slow thinking about it. And I'll put one right here. And one of the things I do is time now m equals, it's not even time now, is it? It's time gap. It's time pass, or pastime, or period in microseconds. This will give it since the computer got switched on. Period microseconds equals microsecs minus period m. And now time since start, microsecs and secs. And this is the little thing that I would then want here. Draw curve gradient. This, I suppose, is more like init array. Draw curve gradient. Then I want this again. Am I right about this? So I take the microseconds, then I take the microseconds again and subtract the last time. Is that really right now? I don't think I'm getting this right, am I? No, I'm not getting this right. I'm too tired to think out the logic of this. You know what I'm saying? What I'm saying is, I feel like I probably am right. Like if this is 100, it's embarrassing to have to go through this in my mind so clearly, so slowly. If this is 100, then 50 passes. Then period m equals 150 minus 100, which is 50, fair enough. Then this is done. Period m equals, let's say, this now equals 50. This takes 200. 200 minus 50, 150. No, because, oh god, so it makes like starts at 100, this takes 50, this takes 100. Starts at 100, period m's 100, comes to 150, period m gets 150 minus 100 to know 50, goes to 250, period m is 50, and it's to become 250 minus 50, which is just 200. So I'm not like subtracting that from this, that doesn't make sense. It's more like I need something separate, like bloody... I do need to store the start in a way, don't I? Or do I? What the hell do I need to store? It's like... last time or something. That's the start. And if I set again and then do that, is that the way I do it? Because that's kind of what I'm doing, showing it at the start, then doing the thing and saying, right, tell me what now is minus the last. Then I set it again. Then I do the thing and then say, okay, tell me what now is minus the last. Then I set it again. I hope I'm right about this. Then I say rendered array to pix map. Find some things like that so hard to think about, and I'm not convinced at this moment that I got that logic right either. We'll soon see. Oh, nearly half an hour already, and I'm just kind of faffing with this and not giving it a really good, thorough test, because there are lots of little aspects of it I need to test. Okay, well, I think that saved that. Now, I think I can just go straight in, say, do it. Right. Start gradient render, that's the microseconds. Init array, 4,000 microseconds. 4 milliseconds to init that array. I wonder if that's really right. Half a millisecond to draw that curve. That's fine, it's a pretty short curve. Render array to pix map, half a second. Does that make sense? 500,000 microseconds? Yep, half a second. And I think that I have got this sum right. I think. Well, it's interesting. It's interesting in as much as that it's extremely slow. I didn't do any kind of comparison with doing the things. I didn't notice any difference. Half a second's a while for 3 recursions. Out of curiosity, and this will probably take a while to build, I will build it in release mode. And I will take this. It's still nice to know that thing about arctan too. And I won't bother with that. I will come to this, and I'll just pop that in there. I'll come back to main, and I'll just say forget about arctan 2. I've heard it all before, and I'll go for it. Now it's compiling the release version, so it's kind of like a fresh compile. I haven't compiled the release version for a while. Lots and lots of things, little things have changed. I must admit, I'm pretty pleased with the state it's in now, even if I don't manage to solve some of the upcoming problems. Having solved the problems, the clipping the line problem. I have done things like that before, but it was probably obvious. It was obvious to me when I was doing it that I had no real recollection of what I was doing. I'm sure I remember the thing about counting the found intersections. Anyway. Okay. Everything should be as before, yeah. So I'll just straight away. Well, let's compare. So, initting the array took like a 1,000th of a second shorter time. Drawing the curve took like a quarter of the time, and rendering to the array took about a quarter of the time. Okay, well, let's see, because the thing to do is to try a trickier render now. Well, I want to render to my display, although I'm running a slightly smaller display just now. What else do I want? I want a problem at the moment with the gradient render is that it's hard to get an impression of how it's actually going to render. But well, let's see. Let's just try something. Let's say that I want the brightest thing to be yellow. I want the darkest thing to be this brown. I want to actually remove that. And I'll leave it like that. I don't need that middle one. But yeah, at least it's a range. I'll keep this so that it is like, I wonder how long that initial find the highest point takes. Now, yes, what I was saying was a problem at the moment with the gradient rendering is it's hard to get an idea about what it's really going to look like. Like, in fact, it's basically impossible. Just now. Depending on how quickly I can get the gradient rendering, I might be able to render a preview of it. Now, So what I'm doing just now is I'm using addition rendering because it's got a sort of similarity to it, although it's not the same. I want to bump up the recursions because I want to try and get an impression of what it is I'm going to be seeing. Even though it's not, it's always just not going to be the same. I've got 1, 2, 3, 4 line segments. How high can I get? 6 recursions and it's still holding up okay. So now for the render, why don't I just try 6 recursions? I am anxious about this. I really because I just have no idea. Okay, save over that image, that's fine. Apparently done. Okay, interesting. It has worked. The lowest color is far too bright. So it hasn't really quite worked. Because I shouldn't really see. Or should I? Well, I suppose I should, because it's only going to have a few divisions. Yeah, I should definitely see. Interesting. No, this is basically working. And let me grab this. I should really give better output than this. I should give details of the number of segments, the number of iterations. Now that one was a much larger. That took more than half a second to do the bit which made the pix map. But this is kind of the more interesting thing. That is nearly a millisecond to do 6 iterations. No, 9 milliseconds. 9 milliseconds. Nearly 100th of a second to do 6 iterations. Okay. Well, honestly, well, how is that? What if I just bump it up to 10 and say go for it again? This didn't take very different time. I wouldn't expect it to. It's the same size of screen. This, yeah, it's starting to get up to taking a second. And it's starting to get a lot more subtle. Much more so. Now the line has disappeared, yeah, as I should expect, because that, whatever it is, g-step variable, as the number of, as the number of times the line crosses itself increases, that g-step variable becomes smaller. So interesting. Now, so what is a thing to do? A thing to do is to take this and push it all the way up to white, but to make this yellow, and apply that and just statically overwrite again. I don't mind. And once again, just out of curiosity, yep, 3/4 of a second or so. Wow, so totally different. But interesting, interesting how, but also very, very washed out. Like, is it really telling me that I think there's a problem with that. Basically, that's what I'm saying. I think there's a problem with that. Let me have another look at the gradient setup. I suppose it does go very kind of... I'll keep it dark, darker longer. And also, I'll just boost up the recursions one more time. I'll take this set. And this is going to be the last time I do it before I go into the code and get better. This is 11 recursions, so I would expect, yeah, like, so these two are very similar. This was a big jump. The next one, I would expect 11 recursions to take a good deal longer. Wow. Oh, sorry, I didn't really see. But it took, well, yeah, it did take a good deal longer, but what it took was 3 seconds. I didn't get a clear idea of that because I didn't see the thing update. Again, array to pixmap about the same. This, 3 seconds, just over. And what on earth did it actually render? Wow, and it's quite disappointing. It's like there's almost none of the yellow. It reaches a lot of peaks. Oh, and look at that. Okay, this is going to need some work because this is not... That is not very good. But no, okay. I'm not unpleased with it, to be honest with you. It's doing some things correctly, but obviously not some things correctly. Somehow, at points, it is breaking through, but also, yeah, other things about it are just wrong. On the whole, though, this is coming along. This is interesting. 42 minutes, so I'm going to have to call it a video there. Next time I'm going to make sure that this outputs something more sensible. Well, not much more sensible, just a few more bits of information. 11 recursions in 3 seconds. I must make sure that I get this information for all types of rendering. And I must figure out if there are things I can shave off. But next time I will be debugging this stuff, because I'm sure in here lies the problems.